Okay, guys, in this session, we'll be looking at how to create numpy arrays using the zero method, the ones method, the linspace method, and the arrange method. So, sometimes when you're trying to create an array, you don't have a given value. In a situation where a given value is absent, it doesn't make any sense to just create an empty array and just leave it like that, right? So you have to store placeholder values inside of this array. Now, these placeholder values could be zeros, they could be ones, they could be numbers you generated from a list or something. So um, you could use these as placeholders inside of your NumPy array. So let's see how we'll make use of. First of all, the first one is called zeros, and then we have ones, and then we have lean space, then we have what's the fourth one? Hold on, let me check the curriculum. Uh, zeros, ones, lean space. Yeah, a a range. Yeah, so we could use this. So let's see how to make use of these four methods to create placeholder values, and then inside of our numpy array. So I would initialize my variable called r, and inside of it, I would say np dot array, right? But I'm wrong. I'm not supposed to say array. What we're supposed to do is np dot zeros. But initially, what we did before previously was np dot array to create an array. Now that was done because we had a given value, right? But in this situation, we don't have any given value and we want to initialize placeholder values for this array. So what we'll do is we'll call np dot zeros, sorry, in small letter, np dot zeros, and then we'll pass in the function inside of the function here. Instead of the function we call here, we're going to pass in an argument with square brackets again, and then I'll pass in. I want to create an array that has. I'll explain this, but for the meantime, let me just write this and then print here. Uh, clear my screen. Explain. Okay, NP is not the. Oh shit! I keep forgetting that I'm supposed to import numpy. I'm so sorry. Say import numpy as np. So this should work now. But yeah, so we just created um, an array that was filled with uh, zeros, right? So the reason why I passed these 3 and 4 here, this is to tell Python or to tell NumPy that we need 3 arrays, right, to be created. We need 3 rows, right? Create 3 rows, an array with those 3 rows and 4 items. 1, 2, 3, 4. So this is like a 3 by 4, a 3 by 4 array, right? A 3 by 4 array. So likewise, the same scenario could be if I'm actually creating a 3 by 4 array, which we've looked at, but I didn't actually explain. Also create a three-dimensional 3 by 4, not three-dimensional array, 3 by 4 array. So I'll say this, and I'm just trying to replicate this same thing here to explain. So it should be 0, comma 0 and 0 dots. I missed a dot here. So I should just make these zeros. There's no point putting this. Let me just leave it like this. And I'll initialize a comma here and a space. I'll just copy this 3 times, right? 1, 2, and 3. So I want to arrange this properly so it looks exactly where it's. So yeah, this is a 3 by 4, 3 rows, an array with 3 rows nested inside of this. This is, and then 1, 2, 3, 4. So if I should print this, I'll call this art2. Let me just, okay, let me do print r2. I should print this. You see, we have the same exact position, like the way it was positioned here. That's the way it was positioned here as well. So this is what we printed here, which is this guy. So this is a 3 by 4 array, right? So if I should also print out array.2.ending, let's check how many dimensions that have. This is a two dimension, right? This is a two-dimensional array because this is the first array holding it, and it has other arrays nested inside of it. If I should still do the same thing here, uh, see, we get 2, 2, right? They are both two-dimensional arrays. But how we now calculate the rows, when I say 3 by 4, I actually meant by the rows, which is 3, 1, 2, and 3, and then we have 1, 2, 3, 4. So using this alone, we just created a 3 by 4 array. We just created this array with fixed with values placed inside of it, right? So that's just how explaining uh, using that second example, explaining np.zeros and 3 by 4 dimensions. So I'm going to get rid of this dot ending, and then I'll clear my console, and I'll print this again. We see we still have our 3 by 4 array, all placed with zeros, right? So let's check for what if we don't want to use zeros. We could say r2. We don't want to fill our array with zeros. We could say ones. We want to fill our array with ones. We could say 2 by 2, right? 2 by 2 array, and yep, 2. And then we run this. Oh, sorry, cannot. Oh, wow, sorry, I made a mistake in my code. Likewise, we should not repeat the same mistake. We should take note of this whenever we are creating an array using the ones method or the zeros method. We should always pass in a second bracket inside of it, unless Python is not going to understand what you're trying to tell it to do. So yeah, we just created an array of 2 by 2, 2 rows, right, and 2 columns, all filled with ones, right? So yeah, so that's for creating arrays using ones and zeros in situations where you don't have a given value and you just want to just impute placeholder values for your NumPy array. So the next thing we're going to be looking at is linspace. Okay, so to actually um, use the linspace method here to create um, a NumPy array. So basically what linspace means actually means is a linear space value. So in case you want to use the linspace method to create values, the syntax for that is r3 equals to np dot lin space, right? And instead of the linspace, what we do is we pass in three numbers. The first number is where you want your linspace to start from, and the second is where do you want it to end. So I'll say 5. And how many numbers do you want to generate between 1 and 5? You want to generate how many? You want to generate 10. Say you want to generate 5, you can say you want to generate 3. So I want to generate 10 here. So I would come down here and then print this to the console for us to see through a CLS. And if I run this, you see, we now have a linear space of numbers. We have the numbers of different values that are being generated using linear space, right? So we say we want it to start at 1 and end at 5, right? Start at 1, end at 5, which is 1 here and end at 5 here. And then give us a linear space of 10 numbers. So if you should count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have 10 here, right? And all these numbers are different numbers that are being generated. So that's for lean space. The next thing we're going to be looking at is how to generate numbers using. Okay, so just as we know, when we are using range, I demoed this when we were learning Python. If we are creating a range of 1 to 5, watch what's going to happen when I take this range, cut it out, put it inside of a list. I'll put it inside of a list, right? And then I'll print it out to the console. Let me comment this out. So yeah, so I just printed a list of range between 1 and 4. But initially I said I need from 1 to 5. So this range, what really happens is that it's going to print out 1 up to 4, but not including 5. If I want to print 5, I'll say 6 here, and it's going to print out 5. So it's going to print out 1 up to 5 and not including 6, right? So we should keep this in mind. So when working with Numpy, I want to create a ranges uh, of numbers inside of our Numpy array. We do the same thing using the uh, say np dot a range this time. But for Python, sorry, this is C Python. Doing it the traditional way, it's range this way, right? But doing it with NumPy, it's called NumPy np dot a range. Then we pass in the value where we want to start and the value where we want it to stop, right? And at this point, I'm going to print ARR for R4. I'll do a CLS here. I'll print this, right? We got the same. We got an array of a range of numbers from 1 to 4, but not including 5, right? So this is everything for creating arrays with placeholder values